Hello guys, welcome on Tesla Adventures. In this video, we are starting the pure rolling motion, and in this first video, we are studying about combined rotational and translational motion as well as pure rolling condition on the ground. So in this first screen, you can see that there is a spherical object, or you can imagine a sphere or a ring, which is being dragged and it is being slipped over a ground, over a surface which is at rest. And in this case, this is a pure translational motion, and due to this fact, in the pure translational motion, the velocity of each point lying on the body is in the same direction, as well as it is equal to each other. Now, if this ring is only rotating about its central axis, I mean to say that if it is hinged about its center, and you can see that this is an axis which is passing through this point and it is perpendicular to the ring. So if this ring is hinged about this point and it is only rotating about this axis, then if its angular velocity is omega, then the velocity of point A will be r omega in the backward direction, and the velocity of point B would be r omega in the forward direction, and obviously the velocity of point O would be 0. So now in third case, if we combine these two cases, if we combine pure translational motion as well as rotational motion, so in this case, if this body is rolling on the ground and it is also moving forward like a normal tire of cycle or some vehicle, you can see that in that case the center would be moving with some velocity, as well as this ring would be rotating about its central axis with some velocity omega. So let's suppose that the radius of this ring is r, its angular velocity about center is omega, its velocity of the center is v. Therefore, the velocity of the topmost point would be the combination of the velocities of pure translational motion plus pure rotational motion. So, if we combine these two velocities for point A, then the velocity of point A would be v plus r omega. And if we combine these two velocities of the center, so the velocity of the center would be only v. And if we combine velocity of point B, then velocity of point B would be v minus r omega, because v is in forward direction and r omega is in backward direction. This is assumed that v is greater than r omega. So the velocity of point B would be v minus r omega. So this is the case of combined rotational and translational motion. Now if we talk about the pure rolling, then we can say that in the case of pure rolling, the velocity of the contact point would be 0. Now, this is the contact point on the ground, and obviously the condition of pure rolling is the fact that the contact point must have the velocity which is equal to the velocity of the surface on which it is moving. So it is moving on the ground, therefore the velocity of the ground is 0, and hence the velocity of point B should be 0. So if the velocity of point B is 0, which was earlier v minus r omega, now if we equate it to 0, then v minus r omega is 0, and therefore v is equal to r omega. So this is the condition for pure rolling on the ground, where v is the velocity of the center of the ring, as well as r omega is the omega is the angular velocity about its central axis, like that. So if we consider the velocity of point A, which was v plus r omega, and now we know that for pure rolling v and r omega are equal, then if we substitute the value of r omega in this equation, then this velocity of A would be 2v and the velocity of point O would be v. So this is the condition for pure rolling on the ground, that v should be equal to r omega. And for accelerated pure rolling, now if we suppose that the center is moving with an acceleration of a, and this system is rotating about the center with an angular acceleration of alpha, then for accelerated pure rolling, it is necessary that V should be equal to r omega at any instant, as well as the tangential acceleration A should be equal to r alpha at any instant. So for accelerated pure rolling, these two conditions must coexist, and for only uniform pure rolling, in which speeds are constant, so the required condition is only V is equal to r omega. So conclusively, on the ground, the relative velocity of the contact point on the rolling object, should be zero with respect to the surface, and obviously the ground is a stationary surface. Therefore, we can say that for an object which is rolling on a ground surface, the contact point must be at rest for pure rolling. Now this is the condition of pure rolling on the ground. Now you must be imagining that how it is possible that this complete object is moving and this contact point is on the ground. So let me show you this by an example. You can see that this is a square block which is toppling over this surface. It is not sliding, in fact, it is toppling like that. So in the other position, this block would be like that. Okay, so you can see that in this case, this point is at rest. The velocity of this contact point is zero at this instant, but after some time the contact point would be changed and the new contact point would be B. Initially it was A. So you can see that this is toppling, and at the instant when A is the contact point, A is not moving, and in this case the contact point is changing. Now the new contact point would be B, and after some time the new contact point would be C, and then D. So contact points are changing, but each contact point is not moving on the ground at any instant. So this is the pure rolling. Now in this case you can see that this is a perfectly rigid round object, and any two consecutive contact points would be so closer to each other so that we cannot see them changing. So at all the instants the contact points are changing continuously, but at any instant the contact point is not moving. So in condition of pure rolling, the contact points are in fact changing, but they are not moving, and we cannot see them changing in a perfectly round rigid body because they are so close to each other that they are not visible while changing. So this is the complete pure rolling. Now in the next video we'll discuss about the condition of pure rolling on some moving surface. Thank you.